Hello, this is Nick Andre. Welcome you to another screencast. In this screencast, we'll be covering Skills Integrated Challenge 6.8.1, planning subnets and configuring IP addresses. In this lab, we've been asked to implement the standard lab topology, but with a new IP addressing scheme. You'll be using many of the skills you have learned, including VLSM, IP configuration, and troubleshooting. To help with the VLSM part, I devised a spreadsheet when it comes to address allocation and address calculation. To begin with this lab, I'm going to open up the PT activity window to see what they're asking us to accomplish. They specified under task 1 that we are given an address block of 192.168.23.0/24. And we must provide for the existing networks as well as future networks. So what I have done is I've taken this area right here and I have mapped it out over to my spreadsheet. So subnet 0, our first subnet, will represent the existing student LAN, which contains 60 usable hosts. I added 2 to this number to address the network address as well as the broadcast address. There's also going to be some room for future growth when it comes to the student LAN, so I'm making that my subnet 1. And according to the packet tracer activity, this future student LAN is supposed to grow up to a total of 30 hosts. The next subnet, subnet 2, is going to contain or represent the existing ISP LAN, which has the server and the ISP's router, and that too will have a total of 14 hosts. The fourth subnet, subnet 3, will be the future ISP LAN, and that'll contain a total of 8 hosts. And lastly, subnet 4, which will represent the existing WAN of a total of 4 host addresses. Let me scroll further down the little list of things to do. And in this next section, we are told how we are to configure our interfaces for each of these devices. Once again, to make this simple for us, I devised a spreadsheet to break down the 3 local area networks into more manageable tables. So the first local area network I'm calling the existing student LAN, which will have 3 devices, PC1A, PC1B, as well as R2. The next local area network is called the existing ISP, and that has 2 devices, the server, which will act as a DNS server as well as an HTTP server, and then the ISP's router, R1. The other LAN technically is a WAN because it joins those 2 previous LANs together, and that only has 2 devices on it, R1 and R2. And on those routers, we have the serial interfaces that are connected together to establish this WAN. So, I got this information from the activity window. I like using a spreadsheet because it gives me the ability to manage and calculate the addresses required to configure these devices. To begin this activity, I'm going to need to calculate the new subnet addresses for these existing LANs as well as future LANs. So let me get rid of the PT activity window and let's put our focus into our spreadsheet. Remember, we are given an IP address block of 192.168.23.0/24. The requirements for each area network can be found in this table. And so I'm going to go over to my next worksheet called Address Calculation. And here you can see that my address block was specified on row 3. And in the 4th octet, that's my host octet. Now I know this is my host octet because this was a /24 address block. So it's telling me the very first 24 bits, that is, the first, second, and third octet, are the network portion that I'm not allowed to touch. Since I'm allowed to touch the 4th octet because that represents the host portion, I have broken it out into the 8 columns that represent each bit of this octet. Remember, subnet 0 was the existing student LAN, and it needed a total of 62 host addresses. Since I'm given host addresses, I'm going to come into this row, row 8, and I'm going to click on the very bottom box on the far right corner. The reason why I'm picking this box is because this represents my subnet mask. And because I'm dealing with 62 host addresses, I have to ask myself one question. How many bits must I leave behind to accommodate 62 hosts. So let's say if I leave this first bit behind, what would the size of my subnet be? According to my spreadsheet, the size of this subnet is going to be 2 total host addresses if I were just to leave the last bit behind. 2 host addresses are not enough to accommodate the first subnet. So what happens if I leave the last 2 bits alone? Well, that gives me 4. So 2 raised to 2 bits gives me 4 host addresses. Still not enough. Let me try it for the next one. Well, now I'm leaving 3 bits behind, not touching them. 2 raised to 3 gives me 8. Still not enough. Let me leave 4 bits behind. 2 raised to 4 gives me 16. Still not enough. Let me leave 5 bits behind. 2 raised to 5 gives me 32. I'm getting closer, but still not enough. So let's see what happens if I leave 6 bits behind. So when I leave 6 bits behind, 2 raised to 6 gives me 64. And that's just about right. So what do I do with these other 2 bits when it comes to my subnet? Well, the only way a computer knows where the network portion ends and where the host portion begins is by using zeros and ones. Any 0 underneath an IP bit represents the host portion. Any IP bit that has a 1 underneath it represents the network portion. So I'm going to put a 1 here and a 1 here. When I do this, my spreadsheet will automatically color the cells above it to a bright red color. This color indicates that these bits are going to be used to represent my subnet mask. Now my goal is to calculate what the network address is going to be and what the broadcast address is going to be. With these 2 pieces of information, I know what my usable range is. My first usable address is going to be the first address after the network address, and my last usable address is going to be the address right before the broadcast. Since this is my first subnet, I'm going to assign it the very first address of this address block, which would be zeros. Now, a network address contains all zeros in the host portion as well. So let me put some zeros in here. And I built the spreadsheet to automatically take these binary numbers and convert them back into decimal. So the network address of subnet 0 is going to be 192.168.23.0. It's going to have a subnet mask of 255.255.255.192. Let me record this information onto my address allocation worksheet. So I go up to row 4. Under the network address block, I'm going to type in 192.168.23.0. Remember, this is where our address block originally began. I cannot fill out the broadcast address just yet, but I can fill out the subnet mask for the existing student LAN by coming down here to row 12 under column F. Let me change this so it's 255.255.255.192. I'm going to be using that information later when I configure my interfaces. Alright, can I fill out anything else now? Let's see. Device 1A's fast Ethernet is going to be the first usable address. Well, the first usable address is the address right after the network address. If my network address is 192.168.23.0, my first usable would be 192.168.23.1. The next usable would be 192.168.23.2. What about the last usable? Well, in order for me to know what the last usable address is, I'm going to calculate the broadcast address. So let me go back to my address calculation worksheet. And the definition of a broadcast address is when you have all ones in the host portion. These bits right here represent the host portion because these are the bits that have zeros underneath it for the subnet mask. So let me change them so they're all ones. So I have a 1 here, a 1 here, and then a 1 there, and a few other ones right here. When I hit enter, my decimal has changed from a 0 to a 63. The important thing here is the red bits did not change. Those red bits are what's used to identify the different subnets. As long as the network address and the broadcast address contain the same 2 red bits, then they belong to the same logical address. Because they belong to the same logical address, they can communicate well with each other. So let me go back to the address allocation table. And now I can fill out the broadcast address cell for row 4, 192.168.23.63. And now that I know the broadcast address, I know what my last usable address is going to be. That's going to be a 62, or a .62. Now I'm using shorthand because in this column, I put 192.168.23 above it, indicating that that preludes the values that I typed out in here. However you create your spreadsheet or whatever you do to calculate your work to get your IP addresses is entirely up to you. To each is their own. Now that I accomplished the existing student LAN, I must accomplish the future student LAN, which is the next largest subnet. Remember, you always start with the largest network and you work your way down. If you look at this list, it was all organized for you, from the largest down to the smallest. Always remember to add 2 to get total host addresses. This column is the values you will use to calculate your network addresses as well as your subnet mask. So let's look at subnet 1, the future student LAN. The total host addresses I need for this subnet is 30. If I do this in order, if this network address is 192.168.23.0, and that's the first address, and the last address is 192.168.23.63, then the next address would represent the network address of the future student LAN because that's the next subnet. So 192.168.23.64, which is the next address after the broadcast address. Let's see what that looks like in binary. So now once again, let me go back to the address calculation worksheet. And let me put that here. Well, a 64, that's a 0 in the 128 and a 1 in the 64 column. Great. And then zeros thereafter. Now, originally, my subnet mask was a 1 and a 1 here, and then all zeros. In a moment, we're going to revisit that. But for now, I want you to notice that this 1 and this 0. See, the next subnet mask, all I simply did was change the very first red bit to the next value. So I rolled this 0 to a 1, and now I'm in the next subnet. That's a little bit magic, if you will. It allows us to jump ahead to our different subnets without having to calculate at all. But in this exercise, we are asked to map out all existing and future networks. So I will take my time mapping these all out as I go, just so we become comfortable with VLSM. Speaking of which, VLSM stands for variable length. Let's look at subnet 1 again. According to our allocation table, subnet 1 only needs a total of 30 host addresses. Let's go back to the calculation worksheet. 30 host addresses. According to my subnet size for subnet 1, with the subnet mask of 1, 1, then all zeros afterwards, that's 64. I don't need all 64 addresses. So I asked myself, how many zeros do I need to leave behind, or how many bits do I need to leave behind for the host to accommodate 32 total host addresses? Well, let me clear out this subnet mask so I can see this in action. If I leave just 1 bit behind, I'm going to have 2. Let me leave 2 bits behind, I'll have 4. Let me leave 3 bits behind, I'll have 8. Another 4 gives me 16. And 5. Wow, look at that. If I leave 5 bits behind, I'll have room to accommodate the future student LAN. So once I accommodate that space, I'm going to fill out the remaining spaces, or blocks, if you will, cells, with all 1s. Interesting, when I did this, now I have 3 red cells. All I needed was 32. 32 hosts allowed me to borrow 1 extra bit from the host portion. By borrowing this 1 extra bit, I'm allowed to make more subnets. In fact, this 0 right here is going to allow me to make 2 additional subnets. This subnet I'm currently on, as well as the next subnet. Well, let's record this information. My subnet mask is at 255.255.255.224. Let me go to the address allocation worksheet. Let me come down here. Oops, I don't have that recorded. I really don't care to record it. I suppose I could create a new column right here to record it if I needed it for later. This makes it easier for somebody else. Let me type in subnet mask. And we said originally it was 255.255.255.192. And this one was 255.255.255.224. All I really care about to accomplish this lab are just the existing LANs and WANs, but since we're being thorough, let me include that table. Okay, now that they are properly formatted and I can identify them for later, let's go back and see if we can figure out the broadcast address for this future student LAN, subnet 1 that is. So let's click on the address calculation. And remember by definition that a broadcast address is when you have all ones in the host part. This is my host part, dictated to me by the subnet mask, so I need to put all ones in there. And when I do that, I get a decimal number of .95. That's the number I'm going to come back to my table and record underneath the broadcast column for subnet 1. So it's 192.168.23.95. Now that I know that address, I can calculate the next network address for subnet 2, which is going to be 192.168.23.96. The reason why it's 96 is because I'm keeping everything all packed together tightly and in order. Start with the largest, work my way down to the smallest. The next address that's available is 192.168.23.96. And this is going to be the network address that I'm going to use to represent my ISP. Okay, let's go back to the worksheet, do some calculations. Subnet 2. Let's see, a 96 is a 0 in the 128, a 1 in the 64, and a 1 in the 32. Do you see how that 1 that I told you was going to be, that 1 bit that I told you is going to be used later to represent another subnet, is being used right now for subnet 2. Okay, the question is, how many hosts will this existing ISP need? How many hosts will this subnet need to have to be able to accommodate the needs for the existing ISP's LANs? Well, according to our table, we're going to need a total of 14 addresses. So let me go back to the calculation table. Since I'm given host addresses, let me go to the subnet box, starting on the right side and working my way to the left. Okay, if I leave 1 bit left alone, that gives me 2. If I leave 2 bits, that's going to give me 4. If I leave 3 bits, that gives me 8. And if I leave 4 bits, that's going to give me 16. That's nice. That's all I need. So from here on out, I'm going to fill out the rest of the table with ones. By doing so, I gained an additional red bit, additional subnet bit, that once again I will use for subnet 3. Let me put a 0 here because I already have the network address of 96 like we established in the last worksheet. And according to by definition, the network address is when you have all zeros in the host. So let me put them in there for us. And there we have it. So the network address for subnet 2 is 192.168.23.96. The subnet mask is 255.255.255.240. So let me put that here. And let me also put it right down here, because this is an existing LAN and I will have to configure it. Okay. Let's see. To finish this up, we're going to need to calculate the broadcast address. So let's go ahead and calculate the broadcast address. And the reason why I say to finish this up is because look at what they're asking me to set up. The server's fast Ethernet is the second to the last usable, and the router is the last usable. Well, in order for me to find out what the last address is, or the last usable, I need to calculate what the broadcast address will be. So let me go back to address calculation. And we know that the broadcast address is when you have all ones in the host portion. This area represents the host portion because I have zeros underneath it for my subnet mask. So let me put in all my ones, and I get 111 for the broadcast address. Let me put that in there. So 192.168.23.111. That tells me that the last usable is going to be .110, and the number before that is going to be 109. Alright, the next subnet, subnet 3, is going to represent the future ISP LAN. This is going to give us room to grow. We know the network address is going to be the next available address for this subnet, so that's going to be 192.168.23.112. Don't know what the broadcast is just yet, so I'm going to go back to my worksheet, calculate that out. But before I go back to that worksheet, I'm going to make a reference that this LAN, this future LAN I should say, is predicted to have a total of 8 host addresses. Alright, let me go back to the worksheet to calculate this out. Subnet 3, we know the network address is going to be 0111, because we said it was going to be 112, and that's what 112 looks like in binary, followed by all zeros. Very good. Since I'm dealing with host addresses, I got to ask myself, how many bits must I leave behind to accommodate 8 total host addresses? Well, if I leave 1 behind, I get 2. If I leave 2 behind, I get 4. If I leave 3 behind, I get 8, which is right on the money, 0 waste. After that, all I need to do is fill in all zeros to let them know that this part is included into the network portion. So I get a subnet mask of 255.255.255.248. I'm going to take that information and record it in my table for the future ISP. So 255, 255, 255.248. Now let's calculate the broadcast address. Go back to the worksheet. Broadcast address is when I have all ones in the host. This area is my host because I have zeros underneath it for the subnet mask. Hopefully by now you're getting the idea. So the broadcast address is 119. Let's put that back in my worksheet, 192.168.23.119. Great. You know, if I was watching this video, I would pause it right now. After what I've learned so far, I would try to calculate the addresses for subnet 4, 5, and 6. Then push play and see how well I did. Now, here's your chance. Pause it, see if you can figure it out. Then when you're done, hit play. So, welcome back. Here we go. Let's look at the existing WAN. We're going to be doing subnet 4. I know the network address for this subnet is going to be 192.168.23.120. I know it's going to be 120 because that's the next available address after the last subnet's broadcast address. Okay? I'm going to make a reference that the total host for this WAN is only going to be 4. Typically, WANs only have 4 total host addresses, but it all depends on how things are configured. So here I am in subnet 4. I know the address to be 120, so I'm trying to convert 120 back into decimal. And I see that there I am at 120. So I fill in the rest with zeros. And I ask myself the same question. 2 raised to what power is going to be able to accommodate 4 total host addresses? 2 raised to 2 gives me 4. So I need to leave 2 host bits behind. So I leave these 2 behind because the host bits are on the far right, and I work my way to the left. If they were subnet bits, I would work my way from the left to the right. After I found the number of bits I need to leave behind, I fill the rest of the cells up with ones to indicate that these are the network bits. Okay, great. My subnet mask is 255.255.255.252. That's typically the standard when it comes to WANs, point-to-points, if you will. So I recorded that information there. I'm also going to come down here and record it here, just so I can reference it later when I'm configuring the WAN link. Now they're asking for the last usable, and that should be used for the interface R1, and they're asking for the first usable for the R2's serial interface. Well, I can tell you what the first one's going to be, because the network address is 192.168.23.120 for this network, the first usable is going to be 121. Now I can also tell you that the last usable is going to be 122, and the reason why I can tell you that is because this network can only handle 4 total host addresses. So the network address is 120, that's the first address. The first usable is 121. The last usable is 122. That gives me 3 so far, so the broadcast address should be 192.168.23.123. Now, let's go back and verify that. So let me go to my address calculation worksheet, and I know by now that the broadcast address is when you have all ones for the host, and according to my nifty little cell that does the decimal conversion for me, 123 is the number. Interesting. Now, what I'm going to do is I'm automatically going to populate the network address, broadcast address for the other future WANs. They're real simple for me to calculate because they're only 4 wide. But if you want to know how to do it, just go back and re-watch the video under the address calculation part. So I know the broadcast address is going to be 127 with a subnet mask of 255.255.255.252. And the next one must be 192.168.23.128. And then the broadcast address for this one should be 23. I think it's 131 with the same subnet mask. Alright, let me save this. Let me go back to my address worksheet just to show you that I wasn't making anything up for you. I know this to be true automatically because it's the same thing. It's a WAN connection. I'm going to do the same thing for this one down here. Now I decided to go left to right because I'm just copying what's in subnet 4. Now we said that the network address must be a 1 here maybe? And then this one must be a 1 here, and then all zeros. And it looks like our network addresses were right. 124 for the subnet 5, and 128 for subnet 6. Let me just check to see if I did that correctly. Okay, we're good. Let's check the broadcast address. Let me put all ones here. 127 for that subnet, and what about this one? 131. Let me check that out. 127, 131. Like I said, feel free to rewatch the video until you feel comfortable doing that. Now that was a lot of work just to create our chart. But trust me, these charts are going to be really handy because when it comes back to configuring our devices over here in Packet Tracer, the biggest problem I'm going to have is what addresses do I need to use for my network to be compliant. Now I know a lot of you are telling me, well, Packet Tracer is a little particular. Must I really use the first IP address for my PC? And the answer to that is no, as long as you use any address with the appropriate range. So they're all within the same logical network. But I must say, if you create this work over here, you can document this. You can put this online for people to read that's in your corporate network so that when they go to add a PC, or when they need to troubleshoot a PC on their network, they know what the numbers should be. So doing the documentation allows you to properly plan your network as well as troubleshoot, if not modify or update. So I would suggest creating some kind of standard in which all of your IT people will follow. And these charts become really handy. Okay, so let's put them in action. In order to do this, I need to connect all my devices together. So I'm going to come down here to the lightning bolt. I'm going to click on the solid. Before I click on it, hold the control key. Now click on it. Click on PC 1A. Click on Fast Ethernet. Click on my switch. Here's a standard I'm going to follow. It's the first PC. It gets the first port on the switch. Let me go to the second PC. Click on Fast Ethernet. Let me go to the switch. Let me click on port 2 of the switch. I see I got some red lights, nothing's happening. That's indicating that either the PCs are turned off or their interface cards are turned off, or maybe both. Alright, let me click on the switch. Now I'm going to click on the Fast Ethernet 0/24. And the reason why I'm doing that is because just like the router gets the last usable address, it'll also get the last usable switch. According to the documentation, this router needs to be connected to the switch via the fast Ethernet 0/0. So I click on that. Okay, unfortunately I have to hit the escape key now, because from here on out I'm either going to use a crossover cable to connect the server to the router, or I'm going to use a serial connector to connect the two routers together. So let me click on the crossover cable. Now if you're wondering why it's a crossover cable and not a straight through, it's because a router is technically a computer. It has an operating system, RAM, storage, and it even accepts input. So two like devices connected together, you must use a crossover cable. And according to the documentation, it needs to be fast Ethernet 0/0. Let me go back to my mediums, and this time I'm going to find the little red Ziegel line. It's actually a little red zigzag line, if you will. And this one I'm going to choose the one with the clock on it. This is called a DCE serial connector. So let me click on that. When you click on the serial DCE, you must click on the first router that's going to have the DCE side of the connection. So in this case, my ISP is going to be the DCE of the serial connection. So let me click on that. Let me click on serial 0/0/0. Once again, I'm only doing that because that's what was told to me by Packet Tracer. Now let me come down to R2. And let me once again click on the serial 0/0/0. A little future note. When you click on the first router, that becomes the DCE. Therefore, the other end becomes the DTE. Alright, I have everything all physically connected together with some medium. Hopefully I used the correct medium. The next step I'm going to do is boot up the devices and configure them. In order for me to read my chart, I'm going to come back over here to my spreadsheet. I'm going to resize it so it can stay up with me while I'm configuring. Let's start off with PC1A. PC1A belongs to the student LAN, and according to my table, PC1A's fast Ethernet gets the first usable address. Alright, so let's click on PC1A. Grab my dialog box and bring it down here for you. I see it's turned off. So let me hit the power button. Alright, past that. Next thing I'm going to do is going to click on the config tab. And then I'm going to come over here and click on the fast Ethernet underneath the interface. And I notice, let me just stretch that out just a little bit for you. As I notice that there is no check mark next to the on box. So not only did they turn off my computer, but they also turned off my interface card. Now it's turned on, let's configure it. They're asking for an IP address. Well, we said it should be 192.168.23.1. They're asking for a subnet mask. They're going to take a guess that this is a Class C address, but we're no longer dealing with classful addresses. Hence, I need to change the subnet mask so it's 255.255.255.192. Alright. Now, I need to configure the gateway for this device as well as the DNS. So let me go up to Global Settings. And where it says Gateway underneath the static option, I need to type in the gateway address for this network. Remember, the gateway for a network is the router's interface for that local area network. According to our table, R2 is the router for this network, and the interface that connects to this local area network for R2 is the FA 0/0. So we should be configuring that to be 192.168.23.62. Now, the DNS server is going to be on the ISP side of things, and that's typically the way it is for home networks. Unfortunately, it's not going to be stored locally, so in order to communicate with the DNS server, I have to go across my routers. So the address for this device is going to be on a different network, and the address should be 192.168.23.109. Now, I know that because, like I said, it should be on a different network, the existing ISP. Because it's on that network, it's going to be the server, which has an IP address of .109. Okay. I believe PC1A is configured. If not, I can always come back and find out what I'm missing. Let me close out of that and let me configure 1B. So grab my box, bring it down, turn the unit on, click the config tab, click on fast Ethernet, scroll over, make sure there's a little check next to the on, come down to the ISP address block, and let me restretch this window out so it's a little bit easier for me to read it. And what I have for 1B, it should be 192.168.23.2. The hard work for this exercise, or for this lab, was really developing the addresses. After that, it's pretty much downhill, just as long as you know where to configure things. So let me go under the settings. Gateway address is going to be 192.168.23.2. It should be the same address that we used in the other computer, because all I have is one gateway on this network. For the DNS server, it's going to be the same, 192.168.23.109. Remember, the DNS server is stored over my ISP's network. Okay, those two are configured. Let's close out of that dialog box. And now I'm going to venture into configuring the R2 central router. So let me click on that, grab my dialog box, bring it down here for you guys to see it. Router's booted up. I see there's a little green light underneath this power switch. So let me click on the config tab. First one I'm going to click configure is going to be the fast Ethernet 0/0. So let me click on that. Let me put a check next to the on box. Alright, let me come down here to the IP address box. And according to this is the gateway for my local area network, and I configured the other devices to use this address for the gateway. And the subnet mask for this should all be the same for this network. Good. Since I'm here, I'm going to go ahead and configure the serial 0/0/0 interface. See, that was nice about doing all that other planning on the spreadsheet. Hey, save myself an extra trip. Here, configure both interfaces. I need to turn on this interface. I'm not going to set the clock rate because remember, this is the DTE side. That doesn't get the clock rate. And the way to remember that, it doesn't have the letter C in its acronym, DCE or DTE. This is the DTE, no clock, no C. Alright, let me click in the IP address block, text box. And this is R2. We're in the serial 0/0/0. And according to my spreadsheet, this address should be 192.168.23.121. Okay. Let me click on the subnet mask. It took a guess because the other interface was configured to have a 192 subnet mask, but like always, like it usually does, it guessed poorly. So we have 255.255.255.252. That's very typical for a WAN connection. And let me close out of this. Okay. I did these. Then I'm going to come back up through here. I'm going to click on the ISP. Grab this box. I see this little green light once again, so the router is turned on. Let me click on the config tab. Let me do the serial interface this time. Let me turn it on. Remember when we were connecting the cable up, this was the first interface to get the cable. According to the packet tracer activity window, this becomes the DCE side. If it is the DCE side, we must set the clock rate. So let me choose not set to 6400. Okay. Where it says IP address, I'm going to go back to my table, and I see that this should be 192.168.23.122. Let me configure the subnet mask of 252 at the end. And now let me configure the other fast Ethernet 0/0. Alright, I see this port is turned off, so let me click on. And in the IP address box, I'm going to type in existing WANs, the existing ISP LANs, R1's fast 0/0 should be 192.168.23.110. Subnet mask. Once again, it took a guess. It guessed poorly. This network should have a subnet mask of 240. Okay. That's configured. Now I haven't set up any static routes yet. I'm just doing this systematically. Connect the devices together, configure the interfaces, then add static routes or dynamic routes, depending on your cup of tea, if you will. Let's click on the Eagle server. Let's configure that. Okay. This one's always tricky to find out if it's turned on or turned off. Oh, there's the power. So it looks like it's turned off. Let me click the switch. It's coming to life. Let me click the config tab. Here I got a whole bunch of things to configure, but the first thing I think I'm going to configure is the fast Ethernet. So let me click on that interface. And if I scroll over, I see the ports turned off. They got really nasty in this lab, didn't they? Now I got to come down here to the IP address block. Click in there. And I'm going to type in, let's see, 192.168.23.109. I got that information once again from my spreadsheet. This should be 240. But this also needs a gateway. Because remember, this is going to be serving information to the world. Since it's going to be serving it, it has to go to the router first to get out of its network. So let me go under the settings under global. And where it says gateway, I'm going to type in 192.168.23.110. That's what I configured the router to be. That's what it must be if this is the gateway or the way out of the network. Interesting. The DNS server. Well, this device is the DNS server. So I could put a loopback address in here technically. That'd save on little performance. But I better just use the IP address of this device to keep things simplistic. By the way, in the real world, if you wanted to use the DNS server for yourself, you would put in the loopback address. Naturally, you would use another DNS server for your DNS server. So this way you establish that hierarchy. But there's no other DNS server on this network, so I'm just going to throw this one in. They've asked me to set up HTTP. So under services, I'm going to click on HTTP. And then I'm going to put a dot next to HTTP on. And there's already one for HTTPS. So that's good. And then they also asked me to set up a DNS server. So let me click on that. I want to turn on this service. And I believe they told me they wanted the domain name address to be eagle-server.example.com. And the IP address for this server, or for this website, is going to be the actual Eagle server itself, which is 192.168.23.109. Now you might be saying, it doesn't know itself? Well, it does know itself. But remember, this IP address is used for the other devices on other networks that we have pointed them to this DNS server. Let me just hit add for a second and I'll better explain that by using the topology. Alright, so this record's added to our table, which is good. Let me close out. Now what I wanted to say was PC1A and PC1B, we configured them to have a DNS address for this Eagle server. So if I were to go to PC1A and typed in eagle-server.example.com, the first thing it's going to need to do is resolve that domain name into an IP address. So it's going to go to the domain name server, which is the Eagle server, and that Eagle server is going to go through its phone book. We just added a record into that phone book, and it says, oh, this address is 192.168.23.109, and it's going to send that information back to PC1A. Now PC1A can now package the request into a packet and send it. Unfortunately, it's going to get to the R2 router, and the R2 router won't know what to do with it because we haven't established a routing table. So let's configure R2 to have a static route. And I want everything and anything to go to the ISP. So I click on the config tab. I'm going to click on static underneath routing. And my wildcards are going to be 0.0.0. So I have 4 zeros. So any network, any size. So my subnet mask is going to be those 4 zeros. Are going to hop to or jump to the 192.168.23.122. That was the IP address for my ISP's serial connection. Let me click add, so that's in my routing table. and let me hit close. Alright, now let me go to the R1 ISP, and I need to configure a static route back. So now R2 will pass the packet to R1, R1 will pass it to the server, but the server will pass it back to R1, and R1 won't know how to send the packet back because it doesn't know where that network is. So I need to teach it about that network. So underneath the routing section, I'm going to click on static, and in the network address, this is where things get a little hairy. I need to type in 192.168.23, but I'm not going to put a 0 afterwards. I'm no longer dealing with classful addresses. This is a class list. The network address for the existing student LAN is 192.168.23.0, ironically. Now I make a big point about that because in future labs, that could have been .64, .96, .112. In this case, it just so happened to be that way. To further illustrate this point, the subnet mask is no longer 255.255.255.0, but rather 192, because that's the subnet mask of this network address, and that's what the router will AND the packets with to determine if they have a match in its routing table. So not only do you have to use the appropriate network address, but also that network subnet mask. With class lists or VLSM, you got to be careful because networks can have varying masks. Alright, the next hop, well, that's going to be R2's IP address of 192.168. Now remember, it's got to be on the serial because local delivery will not work otherwise. So 192.168.23.121. Let me click add. Whoops. And let me hit close. Just verify that I had everything in there correctly. Okay. Now, let me grab my activity window and bring it back over here. It tells me I have 97% complete. Well, let me hit check results and see what else I forgot to do. So let me click assessments. They're just yelling at me that I haven't set up a default gateway for 1B. No biggie. Let me close out of that. Move this out of the screen. Click on 1B. Bring this back on the screen. Go to settings. And they're saying that I used the wrong address. It should have been 62 and not 2. Okay. Sorry about that. Let me close out of that. And if I bring this back to our screen, I see that I have 100%. But folks, the reason why we're doing this is so we can learn how things behave. I turned on DNS and I turned on HTTP. So let's see if that actually really works. Let me grab this out of here. Let me go to 1A. Let me bring this back over to my screen. And let me click on desktop. Let me open up the web browser. And in the URL, I'm going to type in eagle-server.example.com. And let me click go. And I'm hoping some web page might load up. And did I type in the right address? It's not the first time I made a mistake, so let me just verify that. So there it goes. Ironically, it just took a little while. It's funny, it simulates the real world pretty precisely. So we have the Eagle server. It says welcome to eagleserver.example. We have quick links. So it looks like 1A is able to communicate. By the way, the reason why it might have taken some time, sometimes these routers have to finish establishing each other's tables. Let me click on 1B. Let me see if it works over there. Let me go to the desktop. Let me click on the web browser and type in eagle-server.example. This should actually load really fast if all goes well. And it does. So this concludes our lab, Skills Integrated Challenge 6.8.1, Planning Subnets and Configuring IP Addresses. Hopefully you found the spreadsheet to be helpful. I know personally when I do these packet tracers, first thing I'm going to is my spreadsheet. I'm always creating these things over and over again just because it makes it a nice reference that when I go to configure this, my problems aren't lying in my IP address. They may be lying in me typing in something wrong or forgetting to turn something off or on, whatever the case may be. So this was another screencast brought to you by Nick Andre, your at-home instructor. Thank you for your time, and I'll see you in the next screencast.